we've been playing with these definitions. Now we're just going to do some application kind of problems. So here we go. Here's S of t. This is the position in meters. Sorry, typo there. In meters in t seconds. If it's being thrown up into the air and coming down to the moon. All right, what time is needed to reach its highest point? So this is a basic fact that velocity is 0 when an object hits the highest height. So let's go find the derivative. So that would be, and I'm not even going to simplify it. I'm just going to carry this negative 27 over 10, and then 2t, and then plus 27. Okay, so make some room here. So I'm going to set this equal to 0. So set this equal to 0. So I'll move this negative term over to the other side. So I'll get 27 is equal to 27 over 10 times 2t. And then if I multiply by the reciprocal, right, I carry this 27 along, and I multiply by 10 over a 27 times a 2. Will you look at that? 27s cancel, so I can see that t is 5. So sometimes not using a calculator can be nice. Okay, so that's the time needed, right? So that's the answer for part A. That's the time needed to get to the maximum height. So then, what is the second question asking? What is the maximum height? So that's where you plug this time 5 into the original equation, because this is the equation that gives us the height. So negative 27 over 10 times 25 plus 27 times 5 plus a 6. And that's a number. I'm just going to leave it like that. All right, so if we're looking at when something's moving in the positive direction, so that means it's moving up or it's moving to the right. And that's where the velocity is positive. So you can think of positive velocity. Then negative will be moving down or to the left. And we're going to be doing sideways particles here in a second. But negative velocity is when something's falling. And so that has, if a rock is falling, it actually has a negative velocity. If a rock is going up, it has a positive velocity, being thrown up. All right, let's look at this graph here. So these I'm always going to give just nice little parabola things you'll be able to quickly draw. So if this is the velocity function, I know that if I take this, I can factor a t out, and I can see that it's going to cross at 0 and 1, and I know it's an upward-facing parabola, just some basic graphy stuff, right? So there's 0 and there's 1. This is my velocity function. So when graph is moving in the positive direction is when this graph is above the x-axis, right? So let me just not write that. Let me get rid of this. I can make some room here. So the positive direction would be from negative infinity to 0, and then from 1 to infinity, because that's where the velocity is above the x-axis. And so the negative direction would be when it's below the x-axis, so that's 0 to 1. All right, so, I forgot to draw the graph in here. Let's draw it right now. So S of t looks like this. It keeps going. Okay. So that's the S of t. So, and I'll just put this as 4 and this is 6. Okay, so if I want to find out where the particle is moving in the positive and negative direction, I need to graph the velocity. And you know how you graph the velocity. It's like the derivative. So slope 0 means at 4, the slope is 0. It's a positive slope before 4. And it's a negative slope after 4. And it doesn't really matter that it crosses at 6, it just keeps going down. So we can easily see that it's going to be moving in the positive direction before this time of 4. So, and it looks like it doesn't even have it doesn't start till 0. So 0 to 4, it moves in the positive direction, and in the negative direction, 4 to infinity. Okay, so let's talk about speeding up and slowing down. This is an important definition. So speeding up when the velocity and acceleration are the same sign. So you can easily think of it as when you're driving with a positive velocity, and then you step on the accelerator, you do speed up, right? doesn't, the analogy doesn't work so well with negatives, but let's just go with what we've got. Okay, so I've got to draw the velocity and acceleration. Oh, look at that. I gave me the velocity. So I'm just going to rewrite it so I can see the roots, right? So I can see that this is a velocity function, positive x squared. So it's going to be facing up, crosses at 0 and 3. There we go. So that's the velocity. So now I'm going to suggest you draw the acceleration right underneath. So the acceleration is the derivative, right? So that's going to go right back up to here to take the derivative. So I don't have to do product rule. So I get 2t minus 3. So acceleration, where this equals 0 is when t is equal to 3/2, right? So that's right there, and it's a line, y-intercept, looks like that. So make sure you label your graphs for you and for me so we can see where we're at. So there's which ones you're looking at. Okay, so now we want to find out where, let's do the speeding up. So speeding up will be where they have the same signs. So let's see. Where, let's just say we only want for t's bigger than 0. I neglected to say that, so we'll just kind of toss this stuff away. This times bigger than 0. All right, speeding up is where they have the same sign. So let me get a different color here. So 3/2, let's put 3/2 on this graph. Wouldn't that be right there? Yep. Okay, so this is below the x-axis, so it's negative. This is below the x-axis, so it's negative. They have the same sign, so between 0 and 3/2, they're speeding up because they're both negative. You're not looking at they're going up or going down, right? They're both negative, so that means they're speeding up. Okay, so let's look at the next little time interval. So let me get a different color. Here we go, blue. Okay, so between 3/2 and 3, this one is negative, right? This is negative. And between 3/2 and, 3 would be here. This is positive. So they have the opposite signs, right? Opposite signs. And so if it's opposite signs, that's when they're slowing down. So it's slowing down between 3/2 and 3. And we don't include the endpoints, right? Then let's look and see what's happening after 3. So after 3, we've got a positive up here, and we've got a positive up here. So from 3 to infinity, it's speeding up. Let's do one more like this. Okay, so this is, oh, look at that. They gave us the position. So we need to go further. We need to first find the velocity by taking the derivative. 3t squared minus 6t. And I want to be able to graph that. So 3t, t minus 2. So upward facing parabola crossing at 0 and 2. And so then we need to go find the acceleration. So it's easiest to do it from here, right? 6t minus 6. So I'm going to draw it again right below. I think it's kind of easy to find out where they're changing. So this is a graph that looks like that. It crosses at 1, right? If you set this equal to 0, you would see that the x-intercept is 1. All right, now let's go do the looking at the signs. And again, let's do for t's are bigger than 0. So so I can see that 1 must be right there and 2 must be here. Just comparing the graphs, right? So looking here, I see negative below the x-axis, negative below the x-axis. So I know it's speeding up between 0 and 1. And then if I look again at, let me get a different color here, red, okay? Between 1 and 2, it's below the x-axis. Oh, it's above the x-axis. So that must mean it's slowing down between 1 and 2. And then if I continue on looking at after 2, it's positive. After 2, it's positive. So from 2 to infinity, it's speeding up.